afternoon to all. Today we are going to discuss the design thinking, that is DB 5 stages, on topic world-class manufacturing practices. So it is the world-class manufacturing practices means we are concentrating, that is the standardization, achieving the highest efficiency in terms of cost cut down and prompt delivery, efficiency and customer satisfaction, and what we call it is the 360-degree approach of attaining all the possible outcomes of to the fullest. Yes. So we have discussed so many case studies in classroom, that is where like world-class manufacturing means like Japanese technique, the Kaizen technology, etc. But today, now we are going to discuss on the 5 stages of DT. So we are taking this particular topic and we will define the problem. Next, we will empathize. Next, how the problem can be ideated and prototype and testing. So we are particularly taking this topic and we are not going in case like we are not going to discuss on case study basis. So we are going to discuss only with this DT 5 stages. Okay, now like as we have planned earlier, one by one you just explain each stage of the DT.
The empathize stage is the first and the most important stage in the design thinking. When applied to the world-class manufacturing, it focuses on the understanding the real challenges and experience of people involved in the manufacturing process, including workers, customers and other stakeholders. In a manufacturing environment, empathizing means observing the shop floor closely and interacting directly with employees to gain insight into their daily tasks. Managers and the engineers try to understand problems such as machine breakdowns, unsafe working conditions, production delays, and quality issues from the workers' perspectives. This stage also involves in the listening to the customer feedback to understanding the expectation regarding the product quality, customers, and the delivery. Various methods are used in the stage such as the observation, interviews, surveys, and the direct participation of the work activities.
The second stage for define stage. The define stage focuses on clearly identifying and framing the core manufacturing problem based on insight gathering in the empathize stage. In the world-class manufacturing context, analyzing, correcting data, shop floor, observation, work and feedback, converting issue into specific actionable problem statement that impact efficiency, quality, cost and safety. The key activities: identifying root causes using tool like fishbone diagram. Define measurable problems, align the problem with business goals. For example, instead of saying production is insufficient, the define stage.
Third stage, idea generation. The ideation stage focuses on developing effective ways to improve manufacturing efficiency, waste and streamline process. Automation uses machines and smart technology to increase productivity and reduce errors. Total productivity maintenance ensures regular upkeep method equipment to avoid breakdown. Six Sigma uses data-driven method to minimize defect and improve consistency. Strong quality control system help maintain product standards. The 5S method improve workplace organization and efficiency, providing employee training to support continuous improvement and innovation in manufacturing operations.
Stage 4, prototype. Development and test pilot solutions on a small scale for extend and implement a new production data. Test a basic solution techniques or introduce a productive maintenance program in one sector of a plant. The main purpose of prototype is to gather feedback, analyze performance and making a necessary improvement before expanding the solution across the entire organization. It helps in saving time, reducing cost and ensuring better decision making. Overall, prototype is an essential step in involving and continuous improvement as a support and learning and adaptation.
The last stage is test. The test stage is design thinking. Focus on evaluating the effectiveness of solution, implementing during the prototype phase. At this stage, the organization measures how well the proposed changes perform in real manufacturing conditions. This involves
involves collecting data and comparing results against predefined performance. For example, if the new production layout or waste reduction technique has been introduced, managers observe whether there is a reduction in defects, improved workflow efficiency, or faster production cycles. Feedback is gathered from workers, supervisors, and even customers to understand practical challenges. Testing is not one activity, it is a continuous and interactive process. If results are not satisfactory, necessary modifications are made and solution is restricted.
Conclusion. In conclusion, integrating the design thinking with a value-first manufacturing creates a structured but a flexible approach to problem solving and innovation. By focusing on our real needs, clearly defining issues and continuous testing and defining solutions, organization can improve efficiency, quality and productivity. This approach not only support continuous improvement but also will achieve operational excellence and long-term competitiveness in the global market.